All right, let's jump right in. Today, we are cracking the code on what is, without a doubt, the most important part of the IGCSE 0580 math syllabus, number and algebra. Let's get to it. You know, this quote from the official training materials just nails it. The engine room. That's exactly what it is. It's the powerhouse. These topics aren't just one section of the exam. They are literally what powers everything else you're going to study, from shapes to stats. So here's our game plan. We'll start by talking about why this section is the engine. Then we'll lay down the solid foundations you need for the core level. After that, we'll check out the upgrade to extended, look at some super common mistakes, and wrap it all up with your blueprint for success. Okay, so let's get that engine started. Why does this matter so much? Simple. These topics show up more than any others, across all the exam papers. Mastering them isn't just a good idea. It's the foundation for your entire grade. Now, we're going to build this thing from the ground up, starting with the absolute must-haves for the core level. Seriously, these skills are the bedrock of the whole syllabus, so getting them right is completely non-negotiable. Now, here's the kicker with this slide. A ton of these skills are tested on paper 1, the non-calculator paper. Being able to just know how to break down 72 into its prime factors, or having your squares up to 15 squared memorized, that's a massive advantage. These are the fundamentals you have to own. And this really shows you the two sides of the coin at the core level. You've got number, which is all about calculation. But then you've got algebra, which is about manipulation. It's like a puzzle. You're moving symbols around, simplifying things, and pulling them apart. It's a real shift in thinking, from just crunching numbers to working with abstract ideas. This table gives us our first peek at the jump from core to extended. Take sets, for example. Core students, you just need to worry about 2 circle Venn diagrams. But for extended, you're adding a third circle and a whole new language of symbols. Same story with equations. Core is all about mastering linear, while extended throws in the much trickier quadratics. And now for that extended level upgrade. This is where things get really interesting, especially for those of you aiming for the top grades. The extended syllabus doesn't just pile on more topics, it actually deepens the thinking you need to do, building right on top of those core foundations. A perfect example of this is fractional indices. I mean, all of a sudden, a power isn't just a nice whole number anymore. You have to get that a power of a half is just a fancy way of saying square root. A power of a third, cube root. And when you see something that looks nasty, like 8 to the power of negative 2/3, you know you've got a multi-step puzzle to solve. And yeah, the list of upgrades is pretty hefty. You're expected to simplify messy surds, untangle reverse percentages, and master different ways of factorizing quadratics. Then you take a huge leap into pre-calculus with differentiation and advanced functions. The jump in complexity is definitely real. This table on functions really hammers the point home. Core students, you need to be able to plot and spot a few basic graphs. Extended students, whoa. You need to work with a much wider, weirder range of functions, and then use differentiation to find things like gradients and stationary points. It's a massive expansion of both what you know and what you can do with it. Okay, so we know what to learn. But you know what's just as important? Knowing what not to do. This next part is all about learning from the mistakes that students make year after year. Let's turn their errors into your advantage. Let's start with a classic problem, pulled right from the case studies. You see this sequence, 2, 5, 10, 17. You can probably spot the pattern and tell me the next number is 26. But the real question is, how do you find the formula, the nth term, that lets you find any number in that sequence, like the 100th one? And here is the beautiful, structured way to solve it. It's called the differences method. First, you find the difference between the terms, 3, then 5, then 7. Not constant, so you do it again. Find the difference of the differences, and it's 2, then 2. Aha! A constant second difference is the big clue. It tells you it's a quadratic sequence involving n squared. From there, it's just a tiny step to see the full formula is n squared plus 1. Master this, and you can solve any problem like it. Oh, the percentage trap. This is such a common one. When you're asked for a percentage change, you almost always find the right difference. But then, under pressure, you divide by the new number. You gotta remember the rule. It's always the change divided by the original value. Always. This is fantastic. It's a misconception hunt using real student answers. Just look at the first one,
3x times 2x isn't 6x, it's 6x squared. The second one, they didn't factorize fully. They left the poor x behind. And the third one, a simple, classic error with negative numbers. Seeing these laid out so clearly helps you spot them in your own work before you make the same mistake.
All right, we've gone through the content, we've looked at the common mistakes. Now let's pull it all together into a final actionable blueprint to make sure you succeed in this crucial part of the IGCSE. Okay, so if you take only one thing away from this whole explainer, please let it be this. Your success in IGCSE maths really comes down to how fluent you are without a calculator and how confident you are playing with algebra. There are no shortcuts here. It's all about practice, practice, practice. Here is a solid, concrete target for you. 15. That's the number of squares you absolutely have to memorize, from 1 squared all the way up to 15 squared. Knowing that 13 squared is 169 without even blinking will save you precious time and brain power in that non-calculator exam. And finally, let's be crystal clear about this. These formulas you see here, they are not given to you in the exam paper. You are expected to just know them. Percentage change, speed, distance, time, and the compound interest formula. Write them down, stick them on your wall, test yourself until they're as natural as breathing.
So there you have it. We've laid out the content, the structure, the common pitfalls, and the most important takeaways. The blueprint is officially in your hands. So the only question left is, are you ready to start building?